So I work on an experiment called LIGO, which uses lasers to detect ripples in the fabric of space-time from two black holes smashing into each other. And in our study released this week, we described a very interesting event. Interesting for two reasons. The black holes that smashed into each other are unusually large. They weigh each more than 100 times more than our sun. But the other interesting thing about the signal that we saw is that it indicated that these black holes spin. And it's known that black holes rotate, but these particular black holes are rotating faster than we expected black holes would be spinning when they smash into each other, near the limit of what's physically possible. And so this has been extremely exciting. We are trying to understand how these black holes formed, why are they so massive, why are they spinning so fast?
So how significant an event is this?
It is quite exciting, and I think the astrophysics community will leap into action trying to understand where these black holes formed. The field of gravitational wave astronomy, which uses these ripples in the fabric of space-time to learn about things like black holes, is relatively new. It's only 10 years old. It started in 2015 with the very first detection of these ripples. And as we're starting to see this new window on the universe, these new signals of black holes, we're learning a tremendous amount. And this latest event is the most recent and most exciting example.
So can you talk to us a bit more, Eric, about how this collision, this merger and its observation has changed how scientists are thinking about how black holes form?
Yeah, so black holes are thought to form from stars. When a very massive star finishes burning its nuclear fuel, it collapses under the influence of its own gravity and creates a black hole. But based on our current understanding, we expected that most of these black holes wouldn't be spinning very rapidly. And observing two black holes that are spinning so rapidly smash into each other means that somehow they must be spun up. Now, whether this is they're born spinning very rapidly because of the stars that preceded them, or if something interacts with the black hole over the course of its lifetime to spin it up. These are now open questions that we'll have to investigate.
Okay, so what could this discovery lead to?
Oh, it's hard to say. Whenever so this is days old, and whenever you have a theory as a scientist, and then your theory is confronted with data that tells you something about your understanding is wrong, it's hard to know what to make of it. So whether this ends up being something that is simply telling us about stars and how they explode, or whether it's something deeper that is the hint of some new physics that's more significant that we just didn't know about before, time will tell.
Okay, and how important is the study of black holes overall to explaining how the universe works?
So black holes are really having a moment right now. I think that we're living in the decade of black holes, and that maybe even 100 years from now, people will talk about this time in the 2020s as a very exciting time in science, when textbooks are being written in the future. And this is because we're making all these discoveries about black holes, and we're learning that black holes are super important in the way that galaxies evolve. So every galaxy, like our own Milky Way galaxy, has a supermassive black hole in its center, we believe, which affects how the galaxy evolves and how the universe evolves. We know that black holes are connected to the most massive stars and play an important role in creating the universe in the way it looks today.